All right, hi guys. So chapter 4, yesterday you learned, or the last class you learned how to solve a system of equations by graphing them, and then the answer to that system was where the two lines crossed, right? The intersection point. So that's pretty easy if you have a graph, and you can always use Desmos. But sometimes it's a lot easier to do it algebraically by hand, right? To just find what x and y equal by using pen and paper, kind of like you solve an equation using pen and paper. Because graphing, you don't have Desmos, is really tedious. There's different methods for solving systems of equations, and you're going to learn the different methods, and then at the end you can choose which one makes sense for you. Sometimes you will just like one, so you'll do that one a lot. Sometimes you'll be able to look at a problem and go, ooh, this method would work best for this problem, right? So the first method we're going to learn is called substitution. So what does substitution mean? If I said, I know it happens a lot in sports, right? We're going to substitute a player. That means we're going to swap out a player sitting on the bench for one on the field. We're going to take one out and put a different one in. Same idea for equations. We're going to take one variable out and substitute something else for it. So here is what we mean. Let's say you have the system of equations here. There are linear equations, right? They're lines, y equals 6x plus 7, and then 3x minus 8 equals 4. There are 3 steps when you are substituting using that method. First, you need to rewrite equations and solve for one variable, meaning you have to make sure you have y equals something or x equals something, because that's what you're going to use to substitute. And then once you have that, you're going to plug that into the other equation and solve. So you're like, that doesn't make sense, but let's do it. And then those steps will make sense. So step 1, rewrite the equations and solve for one variable. We need y equals something or x equals something. I look over here, I have y equals this, and then this one is in standard form. I already have y equals something, so I don't need to do step 1. It's already done for me. Check, I have y equals something. I have this one. All right. Substitute that equation into the other equation. Okay, so what I know is y equals all of this. So I can take this and plug it in for the y in the other equation. See that y there? I'm going to write all of this instead of that y. So what do I mean? First, I'm going to write 3 times x minus 8. And now instead of writing y, I'm going to substitute all of this in. So I'm going to write 6 times x plus 7, because that's what I'm substituting in for y, and it still equals 4. So step 2 is done. Now it says solve for the remaining variable. Well, now the only variable we have in this equation is an x, so let's solve for it. I have 3x here, and now what I'm going to do next is distribute that 8 in, that minus 8. So what's negative 8 times 6x? Well, that's minus 48x, right? Okay, and what's minus 8 times 7? Well, that's minus 40. I just did that multiplication wrong. It's not 42, is it? 56. See, even your teachers can make multiplication mistakes. 8 times 7 is 56, Miss Harrington. Minus 56. And then it equals 4. Okay, so all I've done so far is distribute this in. I've multiplied that by each one. Okay, let's keep going. Now I have 3x minus 48x minus 56 equals 4. Okay, I have some like terms. I've got a 3x and a minus 48x. I can combine those. They're on the same side of the equal sign. So what do I get? 3x minus 48x, well, that's negative 45x. Okay. And then I'm just going to write everything else down. I still have minus 56, and I still have equals 4. And remember, I'm trying to solve for x, so I need to get x by itself. So in order to get x by itself, let's get rid of this 56. Let's move it to the other side by adding 56. All right, so now what do I have? Now I have negative 45x. Handwriting more sloppy down here. That's gone, and 56 plus 4 is 60, right? Okay, so my last step is to get x by itself is to divide by negative 45. divide by negative 45. So I get x equals negative 60 divided by 45. I think it's going to be, if I can divide both by 5, yeah. What's 60 divided by 5? 12. I think I can divide by 15, right? Because what I end up with is negative 60 over 45. And if I want to make it simplified, I think I can divide by 15 because that will go into that 4 times. So I still have a negative 4 and it'd be 3. So the answer is that what? X equals negative 4/3. Okay. All right. So we've got the X coordinate for our our solution to our system of equations. So now we just need to find the Y. So to find the Y, I just take this number that I got the answer and plug it back into this original equation. So I'll do this part in, let's do another color so you can see. So I'm going to just write this equation up here. The original one, y equals 6x plus 7. Now I know what x equals, so I can plug it in. So I know that y equals whatever 6 times my x is negative 4/3 plus 7. All right. It's just some fraction multiplication to throw us off here, but we can do it. 6 times negative 4 is negative 24. And it's 1/3, so that's still over 3 plus 7. And then we know that negative 24/3, 24 divided by 3 is just 8, so that's negative 8 plus 7. So that is equal to -1. So y equals -1, right? So my answer for this whole thing, my solution is negative 4/3 for x, comma, -1 for y. That is the answer to this system of equations. And you can go in Desmos and check, does it cross there? It should, right? So you're probably like, this is way harder and much more complicated than using Desmos. But to be honest, Desmos won't always be available. So you're going to have to know how to do this algebraically. And this one was a little bit longer just because it was a fraction. But let's try it a couple more times. Let's do this one. X equals y plus 6 and x plus y equals 10. So remember, my first step is to find if I have x equals something or y equals something. I don't need to rearrange. I already know that x equals y plus 6. Okay, so I'm going to substitute that into here. So I'm going to rewrite, instead of x, I'm going to write y plus 6. And I like to put it in parentheses to keep it nice and organized. And then I'm going to write what's left, plus y equals 10. Okay, now I'm going to solve for y. So now I don't have to distribute anything, so I can really rewrite this as y plus 6 plus y equals 10. What are my like terms that I can combine? Well, I can combine this y with this y. Y plus y, well, that's 2y. And I still have plus 6. And I still have equals 10. So now I can solve for y. I get 2y equals 4 because I've subtracted 6 from each side, right? And then my last step will be divide by 2, and I get that y equals 2. Now I know that y equals 2. I'm going to come back in and plug it up here to see what x equals. So I'm going to write x equals, instead of writing y plus 6, I know y is 2, so it's just 2 plus 6. So x equals 8. So my solution to the system of equations is 8, comma, 2. All right. And we're going to do, let's see. I'm going to see if I want to do one more. Let's try one more. So here, remember, step 1 is to see if you have an equation that's already set up y equals x equals. Here I have y equals this. So what you'll start to find out is if you don't have your systems set up with x equals or y equals something, you probably don't want to substitute, because then that means you have to do an extra step. But you can still do that. Sometimes you'll have to reorganize your equations and solve for y or x. So I know y equals 3x plus 1, so let's plug it in here. I'm going to write 6x minus 2. Now, instead of this y, I'm going to substitute all of this in. So that's 3x plus 1 equals -2. Now let's distribute. I have 6x minus 2 times 3x is minus 6x. Minus 2 times positive 1 is minus 2 equals -2. Now let's solve for x. Okay, I can combine my like terms. I have 6x and minus 6x. Well, 6x minus 6x is 0x. It's just 0. So that goes away, and I just have -2 equals -2. What's happening here? Well, does -2 equal -2? Yeah, it does, right? And if you remember from solving your systems of equations, this means that you have infinite solutions. What does that mean? That means, let's see if I can get my, that means what you have here is the same line, and it's just on top of each other. And so I'm going to come over to Desmos and graph those really quick before we log off. 3x plus 1 and 6x minus 2y equals -2. 6x minus 2y equals -2. All right, so let's switch over to Desmos. And you can see. All right, here's that first line, y equals 3x plus 1, this red line. Okay, now here's a second line, this blue one. They are right on top of each other. And because they are right on top of each other, every single point they cross at is a solution. There's an infinite number of solutions because they cross over each other at all times. They're always equal. And so that's why that one had infinite solutions. Okay, you'll get more practice today. See you next time.